Right, welcome to question 7 of the Year 10 interview exam. A scientist produces zinc iodide, ZIN2. Don't worry about that, you've never come across it before, it doesn't matter. But this is the method they used. It's weigh 0.500 grams of iodine, dissolve the iodine in ethanol, add an excess of zinc, stir the mixture until there is no further change, filter off the excess zinc, evaporate off the ethanol. Question says, question 7.1, ethanol is flammable. Suggest how the scientist could carry out step 6 safely. So let's look for step 6, and it says evaporate off the ethanol. To evaporate something off, they must have had to heat it. Right? So the problem with heating something that's flammable, if I heat it with an open flame, I'm going to have an explosion. I'm going to set fire to it. So the question is asking you, how could you heat something without using a Bunsen burner or an open flame? And there's a number of different answers. I'm sure in biology that you used a water bath to heat your little test tubes up. And I'm sure in physics you've used electric heaters to heat water for specific heat capacity questions. So something like that. Use a water bath, electric heater. You could also just leave it to evaporate at room temperature. Anything that doesn't involve a naked flame, anything that demonstrates that you understand that you need to avoid the explosion, get you a mark. Explain why the scientist adds excess zinc rather than excess iodine. So, right, an experimental method question, and there's 3 marks for this, so there must be quite a bit to say. So what they've done is they've taken a mass of iodine and they've put it into some ethanol, and it's dissolved like that. They've then added an excess of zinc, and they've stirred until there's no further change. So they've added an excess of zinc. Why have they added an excess of zinc? Well, if they added an excess of zinc, what can they be sure of? Well, an excess of one reactant means that all of the other reactant must have reacted. Right? That's what an excess means. If there's more of this than I need, it must mean all of that, the I2, has definitely reacted. So for our first mark, we're going to say, well, if we use an excess of zinc, we're going to make sure that all the iodine reacts. Right? Why is that important? Why is that important? Well, if I've used an excess of zinc, I can be sure that all the iodine has gone. The thing about iodine dissolved in ethanol is that it would be difficult to get it out again. If I didn't put enough zinc in, if iodine was in excess, I'd have iodine left over. Then I'd have ethanol with a solution of iodine in it and some ZnI2, some zinc iodide. I've got no way of separating out. If I evaporate off the ethanol, I'll have a mixture of iodine and zinc iodide and no way of separating them out. However, if I have an excess of zinc and use up all the iodine, the zinc that doesn't react will just fall as lumps of zinc down to the bottom, like that. And we know that must have been the case because it says here that they filtered off the excess zinc, because the zinc doesn't dissolve in the ethanol. We know zinc doesn't dissolve in ethanol, and metals don't dissolve in ethanol. They react with the iodine in the ethanol, but once the zinc is in excess, it won't react with the ethanol, it won't dissolve in the ethanol, so it just falls to the bottom. So, for the second mark, I need to get over the idea that it would be difficult to get rid of unreacted iodine from the solution because it would be dissolved, and if I evaporated it off, I'd get my zinc iodide and I'd get a mixture of iodine. I'd get those two things. My product would be polluted by the unreacted iodine. But by doing it this way round, the excess zinc can easily be filtered off. So the 3 marks there are for saying, firstly, I want to get rid of all the iodine, I want to ensure it all reacts. Why? Because otherwise I'd have unreacted iodine in my mixture and it would be difficult to remove, but it's easy to remove unreacted zinc because I can use a simple filter mechanism to get rid of it. Calculate the minimum mass of zinc that needs to be added to 0.5 grams of iodine so that the iodine fully reacts. The equation for the reaction is Zn plus I2 gives ZnI2. So this is your first, we're into question 7 already, finally into question 7, and we've got our first FRAM question. Calculate the minimum mass of zinc that needs to be added to 0.500 grams of iodine. So we can see that 3 significant figures is what we're going to be working to. We're given an equation, we're after a minimum mass of zinc, so let's do an FRAM. So E is for equation, F is for the formulas, and we can see we've got no ratio numbers in there, so it's all nice and easy. R is for ratio, 1, 1, 1. A is for AR or RFM, and we know that, or we're told, look, that zinc is 65, and we're told that I is 127, but we're not dealing with I, are we? I is the atom, I2 is the molecule, it's a halogen, it hangs around in pairs. So the RFM of iodine molecules is 127 times 2 is 254. Moles, we don't know, and mass. Right, so in the mass line, we are told, right, calculate the minimum mass of zinc. So this is our victory box. Zinc, mass, if we can put a number there, then we've won. The piece of data that we're given to work on is 0.500 grams of iodine. There it is, I've put it in there. Our strategy is always go to the moles. We remember our first and most important formula triangle. Mass over AR or RFM is moles. There, like that, divide and divide. So mass over RFM gives me moles. Here's my mass, 0.500. There's my RFM over 254. And I've written in the calculation, so even if I get it wrong with my monkey fingers on the calculator, the examiner can see what I was up to. 0.5 divided by 254 equals, it's 1.969 times 10 to the minus 3. Right, that's the moles of iodine. So I'm going to take that number over to there and say the moles of zinc will be the moles of iodine, 1.969 times 10 to the minus 3, times the ratio number of what I need to work out, which is zinc, divided by the ratio number of what I have, which is iodine, times 1 over 1 is the moles of zinc. Well, 1.969 times 10 to the minus 3 times 1 over 1 is just 1.969 times 10 to the minus 3. Now I've got moles, I can go to the mass. A mass over moles times AR or RFM gives me mass. I've got a moles number, I've got an AR of zinc, so 1.96 times 10 to the minus 3 times 65 equals 0.12795 to 1, 2, 3, 4, 5 significant figures, but I'm going to give my answer in the magic 3 significant figures. So 0.12795 to 3 significant figures. Well, the first significant figure is 1, the second significant figure is 2, the third is 7. I'm going to look to the next one to see if it's 5 or greater, and it is, which means that 7 needs to get rounded up, so it's 0.128 grams. Question 7 continues on the next page. A different scientist makes zinc iodide by the same method. The scientist obtains 12.5 grams of zinc iodide. The percentage yield in the reaction is 92%. What's the maximum theoretical mass of zinc iodide produced in the reaction for 3 beautiful marks? Well, percentage yield is actual over expected times 100 equals percentage yield. So all I'm going to do is substitute in the numbers that I'm given. I am told that he actually obtains, his actual is 12.5. 100 is just in there all together, always. A percentage yield is 92%, so the percentage yield goes there. What is the maximum theoretical mass? So we're being asked to work out what the expected is. So 12.5 divided by x times 100 equals 92%. So I just need to rearrange that. So I can say that 12.5 equals 92.0 over 100. I've divided both sides by 100. 12.5 over x is 92 over 100. And now if I time, oh god, which way around am I going to do it? Times both sides by x, so I get 12.5 equals 92.0 over 100 times x. And now if I divide both sides by 92 over 100, god, this is a long way around, over 92.0 over 100, I've got x. To simplify that, I'll just say 12.5 over 92 divided by 100 is 0.92. So 12.5 divided by 0.92 equals 13.58695 blah. Three significant figures, three significant figures. I want this in three significant figures. Here's my first significant figure. Here's my second. Here's my third coming up, but I need to see if the next one along is 5 or bigger, and it is. So I'm going to round this one up to 13.6 grams. Suggest one reason why the percentage yield in this reaction is not 100%. We've got 4 general reasons why yields are not 100%, but the easiest one is that we could say some product is lost, or we could say the reaction was incomplete. Those are the two best answers for a question like this, but we could also say there was an unexpected reaction, or not all the reactants reacted as expected, and the fourth one is that some of the products might have reacted back into reactants. But let's keep it simple. Let's just go with some product is lost, or the reaction was incomplete. God, this one goes on a bit, doesn't it? 7.6. A scientist makes a solution of zinc iodide with a concentration of 0.100 moles per dm cubed. Calculate the mass of zinc iodide required to make 250 cm cubed of this solution. Right, so a concentration question. We've got two concentration triangles. We've got mass over volume is conc, and we've got moles over vol is conc. And we just need to see how our concentration is measured to know which one to use. So the concentration is 0.10 moles per dm cubed. So moles divided by vols will give us a conc in moles per dm cubed. So it's probably going to be this triangle that we're using. But we also need to calculate the mass of zinc iodide required to make 250 cm cubed of this solution. So we are going to need the RFM of zinc iodide. We were told on the previous page that zinc iodide is ZnI2. So the RFM of zinc iodide is going to be 65 plus 127 plus 127 equals. We've done this already, haven't we? 65 plus 127 plus 127. No, we didn't. That's right. Equals 319. So we've got that. Calculate the mass of zinc iodide required to make 250 cm cubed of this solution. 250 cm cubed we've got to put into dm cubed. So 250 cm cubed, well, to put cm cubed into dm cubed, we're going to divide by 1,000. So equals 250 over 1,000 equals 0.250 dm cubed. Right, how many moles are we going to have in 250, 0.25 dm cubed of 0.100 moles per dm cubed? So I've got a concentration, I've got a volume. that will give me a number of moles. So 0.100 is the concentration times the volume 0.250 equals 0.025 moles. Now I've got moles, I can go to the mass. I know that the previous question, mass over RFM, gives me moles. I've got moles, I've got RFM, I need to calculate mass, so 0.025 times the RFM will give me the mass required. 0.025 times 319 equals, doesn't seem right, this is 7.975 grams. Three significant figures, let's go with three significant figures. That's the first one, second one, the third one, and we can check to see if the third one is 5 or greater, and it is, so it's 7.98 grams. And that's the end of question 7.